Hi everyone, today we're going to do a general overview of the equations of conics. So there are four different conics that you should be familiar with. One is a circle, one is a parabola, one is an ellipse, and the last is a hyperbola. So this is what the general equations for conics looks like. You'll have ax squared plus cy squared plus dx plus ey plus f equals 0. You might notice that the b term is missing, and that's something we're going to talk about in the future. We actually will have a rotated conics in that case, and it's going to have an xy term. But for now, we're just going to work with non-rotated conics. So this is what the general equation looks like, and you can tell just by looking at the general equation which type of conic to expect. So if A and C are equal, you can expect to have a circle, which makes sense because the general form of an equation for a circle is x minus h squared plus y minus k squared. So there's no coefficient or denominator for either x or y. If A times C equals 0, you can expect to have a parabola. What's happening there is that either x squared or y squared has a coefficient of 0. One of them does, which means that you'll just have x squared or y squared, which makes a parabola. If A times C is greater than 0, you can expect to have an ellipse, which makes sense because the standard form for an ellipse is a sum of x minus h squared and y minus k squared, so both of them are positive. And if you have A times C is less than 0, you can expect a hyperbola, because if you remember, the standard form for a hyperbola is a difference between x minus h squared and y minus k squared, or vice versa. So one of those values is negative. So if you multiply their coefficients, it's going to be a negative value. All right, so let's give one of these a try together. We're first going to classify the conic, and then we're going to write it in standard form, find all of the important information, and then sketch a graph. So just by looking at this equation, if I multiply my A and my C values, I get a positive number, so I can expect this to be an ellipse, but we do need to write it in standard form. So first I'm going to group my x terms, and I'm going to factor out 9, so I'm going to have x squared minus 6x, and I'm going to need to complete that square. And then I'm also going to group my y terms, and I'm going to factor out 4, so minus 2y, and I'm going to need to complete that square. And I'm going to move 59 to the other side. Now from here, I can see that for my x trinomial, the number that completes that square is b over 2 squared, which is 9. But I'm actually adding 81 to both sides. And then I can see that for my y term, the number that completes that square is a 1, but I'm actually adding 4 to each side. All right, so now I'm ready to factor out my trinomials. So I'll have x minus 3 squared plus 4 times y minus 1 squared equals 144. So this is not in standard form, so I am going to need to divide both sides by 144. So I have x minus 3 squared over 16. Remember, we do need to divide both terms by 144, so I have y minus 1 squared over 36 equals 1. So we can see that this is, in fact, an ellipse. Since the larger denominator is under the y, we know that it is a vertical ellipse. The center is at HK, so our center is going to be at 3, 1. I know that our A value is going to be 6, because this is a squared. Our b value is going to be 4 because 16 is b squared, so our b value is going to be 4. And we can find c squared. Remember, for an ellipse, the equation is a squared minus b squared. So 36, or c squared equals 36 minus 16. So c is going to equal 2 root 5. So since our c value is 2 root 5, and I know that we have a vertical ellipse, I know that I'm going to start at my center and move up and down by that C value to find my foci. So I'm essentially going to add and subtract 2 root 5 from my Y value. So the foci are going to be at 3, 1 plus or minus 2 root 5. For my vertices, I know that I'm going to take my A value and add and subtract them to the Y because I'm going to move up and down because it's a vertical ellipse. So I'm going to have 3, 7, and 3, negative 5. And I know that I can find my minor axis vertices as well by taking my B value and adding and subtracting them from the X value to move left or right. So you can find those as well. So it would be at 7, 1, and negative 1, 1. So now we have all of the information that we would need to graph. So let's go ahead and sketch out a graph over here. This is just going to be a really rough sketch. So we have a center at 3, 1. Then I would go up 6, plot a point, down 6, plot a point, right 4, plot a point, left 4, plot a point, and then do your best to connect them to look like an ellipse. And then I know that my foci would be here and here. So that is all for our ellipse. All right, go ahead and pause the video and see if you can give this problem a try. Okay, so here we have a hyperbola. We can tell by looking at our equation because A times C is a negative number. So first you need to group and complete the square, and you'll see that what we end up with is a vertical ellipse. I know that it's vertical because my Y term comes first. My A value is 3, my B value is 5, and remember C squared is A squared plus B squared, so C will be square root of 34. Our center is at 0, 2, and from there we can go up 3 to get a vertex and down 3 to get a vertex. Also from our center we can go up root 34 and down root 34, so here's where our two foci are. Here, since rise over run in this case is going to be A over B, I know that the slope of our asymptotes is going to be 3 over 5, and conveniently our center is also the y-intercept, so our y-intercept is 2. So these are the equations of your asymptote. So our graph includes all of the crucial pieces of information, so we are good to go. All right, that is all for today. Thank you so much for watching.